Dear student, today I am going to give a lecture on lubricants. So it's a continuance of previous topic, lubricants. In the syllabus, you have subtopics. The topics to be covered in this lubricants. Lubricant definition, mechanisms of lubrication, mechanisms of lubrication, one, two, three. Characteristics of lubrication. Last one, properties of lubricants. First one, definition of lubricants. So lubricants, the substances when you introduce between moving, rotating and sliding surfaces, it keeps this lubricant, this substance keeps them apart, moving, rotating and sliding surfaces, and it will reduce the frictional resistance. Heat generation, it minimizes the heat generation also. So let me take simple example. When you introduce rotating surfaces, sliding surfaces, this rotates this side, this moves this side, this rotates anti-clockwise. We can observe in machinery, clocks, light machinery, heavy machinery, rice mills. So one surface moves this side, this rotator moves clockwise, this rotator moves anti-clockwise. The place at which they touch each other, it generates heat. Usually when you rub two hands against each other, it will generate heat like that. If all machinery are made up of heavy metals, while rotation, during the pause of rotation, movement, when they touch each other, generated heat about 80 degrees centigrade. So it damages the surface because of heat generation. Another name for that, frictional resistance, physics terminology. So you can daily life experience, purely hands are made up of organic. When you rub two surfaces, hands against each other, heat generates. So that helps in getting a heating of our body. So in heavy machinery, like watches in light machinery, heavy machinery, medium machineries, so metallic surfaces rotate against each other, slide against each other, rotate against each other, sliding each other. The place at which they touch each other, heat generates. To minimize that heat generation, to reduce the frictional resistance, we introduce substances. That substance is called lubricant. Right? You can write definition in your words. Substance which is introduced between moving, rotating and sliding metallic surfaces to reduce frictional resistance or to minimize heat generation known as lubricant. So you can compare, all oils act as a lubricants. So when you pour water, this surface some slope is there, pour water flows easily, while pour oil over the surface, slightly inclined surface, it does not flow easily when you compare it with water. That is the specific characteristic of all oils. So all oils act as a lubricant. That we will discuss in properties, right? So next, mechanisms of lubricants. Mechanisms of lubrication. First one, thick film lubrication. Thick film lubrication. 2, thin film lubrication. Also called boundary lubrication. The last one, extreme pressure lubrication. Extreme pressure lubrication. Right. 3 types are there. First one, thick film lubrication. So keeping in diagram in mind, you can write down points related to it. So lubricating oil introduced between moving, rotating, sliding surfaces is thicker. Its thickness say above 1000 angstroms. 1000 angstroms. So of course you cannot see with naked eye. For explanation, so diagrams are mentioned in the textbooks. Same diagram here. By taking same diagram, so I am going to explain. So thick film, thickness of film formed. Film lubrication. When you apply lubricant between moving, rotating surfaces, film formation takes. Thickness of this film form is above 1000 angstroms. 1000 angstroms. And when you introduce between moving, rotating and sliding surfaces, sliding metallic surfaces, the main role of lubricant is it keeps them apart and it reduces the frictional resistance. So as long as they do not touch each other, no heat generation, no damage will not take place between moving, rotating and sliding surfaces, right? So the thickness of the film applied is about 1000 angstroms, 1000 angstroms. So in this type of lubrication done, this type of lubrication is called thick film lubrication. This lubrication is done, you can write some points. This type of lubrication applied under the conditions low load and high speed in the machinery, right? It keeps when you apply this thickness film formed is above 1000 angstrom. Thickness of film above 1000 angstroms. It keeps them apart, the moving. We can mention every time moving, rotating, sliding surface, sliding metallic surfaces, keep them moving, rotating, sliding metallic surfaces apart. It separates moving, rotating, sliding surfaces so that it minimizes the frictional resistance. Consequence of this minimizes frictional resistance. and minimize the damage. Heat generation, it means heat generation. Minimizes the heat generation. Heat generation. We can also mention minimizes the heat generation. Okay. Minimizes the heat generation. Minimizes the damage. Damage. Right. Consequence of this, it minimizes heat generation and damage. So, the main oil that we use under these conditions, low load, high speed. Low load, high speed, or long chain hydrocarbons. Oil that we use as lubricant. Long chain, oils of long chain hydrocarbons. Oils of long chain hydrocarbons. Example where we apply this kind of lubrication. Low loaded, like watches, clocks, low load, high speed, continuously, as long as battery in condition, rotators move clockwise, anti-clockwise, right? So to avoid damage between the place at which they touch each other, we introduce lubricant, maybe semi-solid, solid, or oils like this. Lubricants. So light machinery, all will come. Clocks, watches, bearings, the best example. Next, thin film lubrication. When you apply lubricant between moving, rotating, sliding surfaces, just for explanation here, when you introduce between moving, rotating surfaces, the oil layers, two layers are there, one layer over the another layer, just for explanation only. You cannot see, even when you apply any lubricant between moving, rotating, you cannot see this kind of layers, just for explanation. So gaps will get filled, gaps of metal, rotating, moving, sliding surfaces get filled with oil packets. You cannot see with naked eye. For explanation, mentioned same diagrams are there in the textbook. So I consider same diagram for your explanation. So this film form, when you introduce this lubricant, film form is thin. Thickness of film is less than 1000 angstroms. Less than 1000 angstroms. Only specific this type of lubrication applied under the conditions are reverse to this. Here low load, high speed. Low load, high speed. Here high, this type of lubrication applied, thin film lubrication. This type of lubrication done under the conditions of point number 1. Under the conditions, reverse to this, high load, and low. When it is high load, obviously it moves, rotates, slides, rotates slowly. High load, low speed. So normal oils that we use in light machinery, we cannot use that oil. Here high load is there, they cannot withstand, they cannot bear load. So we need to add some different oils, right? So that oils, when you introduce this specifically made oils between moving, rotating, and sliding under the conditions of high load, this oil, lubricating oil, get adsorbed on the metallic surface of moving, rotating surface. When lubricant applied, like vegetable and animal oils, animal oils. These will get absorbed on the surfaces, on the metallic. Applied, get, will get absorbed, will get absorbed on moving, rotating on metallic surfaces of moving. You need to mention every time: moving, rotating, sliding surfaces. So when it get absorbed, it can bear load. It keeps them apart. It can bear load. This also some different points. So applied absorbed on metallic surfaces. Film form, thickness of film formed. Thickness of film is less than 1000 angstroms. Less than 1000 angstroms, right? It can bear high load, and keeps them apart, keeps them apart, keeps them means metallic surfaces, moving, rotating, sliding surfaces, and minimizes the frictional resistance. Minimizes the frictional resistance. And it will remain in place. You can also mention one more word. It can remain in place. Film formed, remain in place. Between moving, rotating, sliding surfaces. Between metallic surfaces. Right? These are the important points. In this, some points are different from first film. Less than thickness. When it introduced between moving, rotating, sliding surfaces, thickness of film is less than 1000 angstroms, and this lubricant get absorbed on moving, rotating surfaces, so that it can bear high load. So conditions are high load, right? High load, and without causing any damage to the metallic surface, and minimizes the frictional resistance also. The oils that we use this kind of lubrication are vegetable and animal oils. Example oils you can mention same. Oils of vegetable and animals, right? Heavy machinery. This type of lubrication applied in heavy machinery. Alright. The last one, high pressure lubrication. So high pressure, extreme high pressure and high temperature. Under the condition of extreme high pressure and high temperature, we cannot apply normal domestic lubricants. When you apply normal domestic lubricant under the conditions of high pressure and high temperature, they cannot remain in place. They flow out of the machinery. So specifically made lubricants need to be applied. Specifically made lubricants are under the conditions of, so there is no diagram, just important points are there. I like to say those important points. High pressure under the conditions high pressure and temperature, normal lubricants as we used in thick and thin film lubrications 1 and 2. 1 and 2 cannot be applied. So high temperature and high pressure, they may flow out of machinery. As they flow out of machinery. So specifically made lubricants, specifically made lubricants like chlorinated esters, 1, 2, sulfonated oils, 3, glycerol esters. When you apply these lubricants under the conditions of in the machinery of metallic surface of moving, rotating under the conditions of high pressure and temperature, where working temperature is very high, obviously pressure will also be very high. Under those conditions, specifically made lubricants like chlorinated esters, sulfonated oils, glycerol esters or phosphonated esters, they directly react. These lubricants directly react with metallic surfaces. Metallic surfaces of moving, rotating and sliding. Sliding surface, metallic surfaces. So they can they will remain in place and minimize the frictional resistance. Then they minimize frictional resistance. These are the important points. So in extreme pressure lubrication, under the conditions of where conditions are working conditions are high temperature and high pressure, under those conditions you cannot apply normal lubricants. If you apply normal, they cannot place. They flow out of, they lose their oil nature or viscosity. They do flow out of the machinery. So which will lead to moving, rotating, sliding surface touch each other. When they touch each other, because of frictional resistance, damage of metallic surface takes place, machinery. So 3 important thick film, thin film and extreme pressure lubrication. These are the 3. So properties of lubricants. Properties or specific characteristics. Properties of lubricants. So we will discuss specific characteristics of lubricants later at the input. So properties of lubricants are mainly viscosity, 2, flash and fire points, 3, cloud and pour points. First one, viscosity. So all oils having specific characteristic, that is called viscosity. So just the beginning I try to explain that. So when you take water and oil, smooth surface having slope, pour water on smooth surface. it flows easily. Same, you take any oil or lubricant, pour on the surface which is having slope, slight angling is there, so it does not flow easily. That characteristic is called oiliness. Another name for oiliness is viscosity. Oiliness. So another name for this oiliness is a viscosity. So you can define in your own words. Daily life experience. Oil, when you pour oil over the surface, it does not flow easily. It flows very slowly. And it resists its own flow. Oiliness is a specific characteristic. It resists its own flow. That is called oiliness or viscosity. Oiliness is a specific characteristic of all lubricating oils, all lubricants which resist their own flow. So this viscosity is a temperature dependent factor. Viscosity, temperature dependent factor. On increasing temperature, viscosity decreases. Temperature defect. So oiliness decreases. Flowing nature increases. Oiliness decreases. Oiliness, viscosity or oiliness decreases. Flowing nature increases. So next to flash and fire points. Flash and fire points. Fire points. Fire point we know very well. We experience in daily life. Fire point. Any oil, any fuel burns easily in excess of oxygen. So when sufficient vapors produce the minimum lowest temperature, fire point. So before reaching fire point, flash point is there. So vaporization takes place. That indicates complete. All fuels, all lubricants undergo combustion, burn easily in excess of oxygen. So when they will burn, that's important. So liquid cannot combine with oxygen. So vapors of oil, vapors of lubricant, vapors of fuel combine with oxygen. So immediately gets ignited. So sufficient, when it forms sufficient vapors, that indicates the minimum temperature at which sufficient vapors form. It is called flash point. Flash point is a minimum temperature at which oil gives sufficient vapors which ignite for a moment, right? Indicates vapors are formed yet to combine with oxygen, so completely burns. That is called flash point. So before reaching fire point, flash points is a very, very important. So machinery there where we use oils, we need to be analyze their flash and fire points. So once you cannot use oils where working temperature is very high in the machinery, you cannot use oils which are having low flash and fire points. So we need to separate based on the requirement in a different situation at different places. Fire point is a temperature. Fire point, temperature at which vapors of oil combine with oxygen. It is called charge. So of course you cannot use for lubricants, but we use that word for all fuels. So where right, oils just like fuels. So vapors, sufficient vapors, enough vapors gives temperature at which vapors combine with oxygen, or sufficient vapors, enough vapors, sufficient vapors, oils give sufficient vapors, and ignite, get ignite continuously, just for a moment, their flash point. So that indicates vapors are formed. Here, this is a temperature at which vapors and sufficient vapors and combine with oxygen. So it is called, once charge is formed, it burns completely. That temperature is called fire point. So before this is a very, very important flash point. We should know the flash point where we apply in different machinery. So we can take precautions, minimize the fire hazards, explosions. We can avoid explosions like that. Next to cloud and pour point. Pour points. So lowest temperature, so reverse to the furnace, where some oils, lubricant oils, we also use in Jammu and Kashmir, where temperature is less than 10 degrees centigrade. We also use machinery, guns, two-wheeler, four-wheeler, in Himalayas, where temperature is minus 15 to even sometimes minus 40 degrees centigrade also. You cannot use these lubricants in the machinery. We are working at living in Himalayas region, or poles at the poles. So those lubricants are different. There we need to consider their cloud and pour points. So flash and fire points, an increasing temperature, above room temperature. Average at surface room temperature is about 27 degrees centigrade. So suppose kerosene oil is there, its flash point is about 38 to 40 degrees centigrade. Fire point is about 48 degrees centigrade. So difference between flash and fire point is between 5 degrees centigrade to 35 degrees centigrade approximately. So fire point is much greater than the flash point. So when it reaches flash point, we can take precautions to avoid fire hazards or others. So cloud and pour points, this can be applied in cold regions. There also we use machinery. You cannot apply normal buildings. There we need to consider cloud and pour points. So lowest defined as lowest temperature, cloud point defined as lowest. No, I will use low word. Low temperature at which oil becomes cloudy or smoky, right? So solidification, it indicates is about to solidify. So when it solidifies, oil in the machinery solidifies, it will cause jamming of machinery, right? So it indicates warning. It's useful, cloud point useful for make us alert, so that we can avoid jamming of machinery. Right, this point is the lowest temperature at which oil becomes cloudy, smoke. So about to solidification. So next fire point is further lowest temperature. It's the lowest temperature, lowest temperature at which cloudy, next stage, cloudy oil gets solidified, freezing, right? Once it solidifies in the machinery, moving, rotating, sliding surfaces, it will cause jamming of machinery. Machinery does not work. So these are the very important. Next, characteristics of lubricating oil. Important characteristics of lubricating. Specific characteristics of lubricant. Third one. Specific characteristics of lubricants. You can write all the points that we covered that already there in thick film, thin film. When you apply lubricant between moving, rotating, sliding surfaces, lubricant, what does lubricant do? It keeps their moving, rotating surfaces. You can include those points also. It avoids frictional resistance. It will remain in place. Those are the important characteristics of lubricant else, right? You cannot introduce other than lubricants like water. They flow out of the water. So only oil which are having viscosity, we introduce between moving, rotating surfaces. So all points that covered, you can also include in this. You can include on when lubricant introduced lubricant between moving, rotating surfaces keeps the metallic surfaces. Metallic, already I mentioned many times, metallic surfaces of moving, rotating, sliding surfaces, apart and avoids frictional resistance. Frictional resistance. Next, 2. It should remain in place. It should remain in place. No need to go through any textbooks. Already we experience in daily life. The chemistry subject that relate to our daily activities and also relate to our survival, our living, quality of living. That depends on chemistry and biology only. Very, very important. So other subjects just to withstand in a society, right? So it should remain in place, so that when it will remain in place, as long as viscosity is there, it will remain in place. If once its flowing nature increases, it flow out of the water. Once it loses viscosity, once it loses its oiliness or viscosity, it will flow out of the machinery. So consequence of that, moving, rotating surfaces touch each other. Once they touch, so it will cause heat generates in addition to working temperature, and it damages the metallic surfaces. Right? Remain in place. It should act as a coolant. It should act as a coolant. 3, 4. It should reduce maintenance of machinery. It should increase durability of machinery, right? And low maintenance. It should reduce maintenance already there. So should act as increase the durability of machinery. Like that. So many points are there. Mainly the very important points are 5 are there. You can include any other extra point of view. So with this I conclude. So in the next class we are going to discuss. I am going to discuss unit 4, that is polymers. Engineering chemistry R22 curriculum. The R22 curriculum. Okay. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.